So today we're looking at topic 3 study guide, multiplying whole numbers. We're actually going to look through all the different strategies that you guys have worked on these last few days. So we'll hit the area model, we'll hit the stacked method, which is the partial products method, and we'll hit the US standard, which is our traditional algorithm. Let's take a look at number 1. Caden earns $25 each time he sells a llama-shaped donut. Caden sold 29 donuts in the month of July. How much money did Caden earn in July? I understand that they're asking me to multiply these two. So we're actually going to do our traditional method for this one. We have 29 donuts at $25 each. So if we write 29 times 25, we have 5 times 9, which is going to be 45. We're going to regroup that 4 up here. 5 times 2 is 10, plus 4 is going to be 14. And that means we're done with this 5. It multiplied the 9, it multiplied the 2, we can cross it out. When we cross out, it tells us go to the next row. How many numbers have I crossed out? It was just the 1, so we can put a 0 there. 2 times 9 is going to be 18. Put our 8 right there and regroup the 1. 2 times 2 is 4, plus 1 more is 5. We're done with that 2. We would go to the next row, but there are no more numbers we can multiply, so we can just add these up. We have 5 plus 0, which is 5. 8 plus 4 is 12. Regroup the 1. 5 plus 1 is 6, plus 1 more is 7. So Caden makes $725 in July. Let me go ahead and clear that. Number 2. Let's scroll down. Oops. Alicia bought 15 bags of candy. 8 of the bags weighed 27 pounds each. 7 of the bags weighed 132 pounds each. How many pounds of candy did Alicia buy? Well, I know that these 15 bags that they're talking about is really this 8 bag and this 7 bag. And I know 8 of those bags are 27 pounds each. So I want to find out how many pounds those bags are altogether. And I know the other 7 bags are 132 pounds each. In the interest of time, I will use the traditional algorithm again for this one. I'm going to do 27 times 8 on this side, and over here I'm going to do 132 times 7. I know that I have to add these at the end because I want to know how many total pounds of candy that Alicia bought. 8 times 7 is 56, so I put a 6 here, and I'll regroup my 5. 8 times 2 is 16, plus 5 more is 21. So I know that these 8 bags altogether were 216 pounds. For the 132 pound bags, I have 7 of them, so I'm doing 132 times 7. 7 times 2 is 14. Regroup the 1. 7 times 3 is 21, plus 1 more is 22. Regroup the 2. 7 times 1 is 7, plus 2 more is 9. So all 7 of these bags together weigh 924 pounds. I want to find the total amount of pounds that she bought. So I'm going to do 924 plus 216. And that's going to be 4 plus 6, which is 10. Regroup the 1. 1 plus 2 is 3, plus 1 more is 4. 9 plus 2 is 11. So I know that altogether, Alicia bought 1,140 pounds of candy. Moving on to number 3. Miss Toots bought a case of pencils at the beginning of the year. The case had 48 boxes with 24 pencils in each box. She wants to give 8 pencils to each of her 23 students to begin the year. How many extra pencils will she have after she gives the pencils to her students? Well, this sounds like she bought way too many pencils. So let's figure out how many pencils she has first. She has 48 boxes with 24 pencils in each box. So I probably have to multiply those two to figure out how many pencils she has. And then she wants to give away 8 pencils to each of her 23 students. So I'll probably have to multiply those two as well and then take it away from the amount she has. Let's go ahead and set up our stacked method. We have 48 times 24. Remember, this is also called the partial product method. We're going to do this first. We're going to take the 4 and we're going to multiply the 8. This is really just the 4 because it's 4 ones and this is 8 ones. 4 times 8 is 32. Next, I'm going to do this 4 times this 4. Well, this 4 is really a 40. So I'm going to do 4 times 40, which is 160. And let me go ahead and write that on the side so we can see it. This was 4 times 8. This is 4 times 40. Next, we have this 2 times this 8. Well, this is really a 20, so this is 20 times 8. And that's going to be another 160. And I'm going to write that over here so you can see it. 20 times 8. And now finally we have this 2 times this 4, which is really 20 times 40, which is 800. Now I'm going to put 20 times 40 right here. Now I'm done multiplying. I'm going to add all of that up. 2 plus all of these zeros is going to be 2. 3 plus 6 is 9. Plus 6 more is 15. Regroup the 1. 1 plus 1 is 2. I know that I can combine that with the 8 and make it 10. Plus 1 more is 11. So Miss Toots bought 1,152 pencils. Now, she wants to give 8 pencils to each of her 23 kids. So I need to figure out how many pencils that is. Let's go ahead and erase this section over here so I have some space. This will take a while. If she has 23 times 8, we're going to do the stacked method again. 8 times 3, these are really just 8 and 3, that's 24. So we're going to put 8 times 3 here. And then we're going to do this 8 times this 2, which is really a 20. So that's 8 times 20. And that's going to be 160. And I'm done with my multiplication, so now I have to add. 4 plus 0 is 4. 2 plus 6 is 8. Nothing plus 1 is 1. So she's only giving away 184 pencils. And I know she's giving them away, and I want to find out how many extras she has. I'm going to do 1,152 minus 184. 2 minus 4, we can't do it, so we have to borrow. 12 minus 4 is 8. 4 minus 8, we can't do it, so we have to borrow. 14 minus 8 is 6. 0 minus 1, we can't do it, so we borrow. 10 minus 1 is 9. So we know that altogether she still has 968 pencils. Moving on to number 4. "20 middle schools are collecting canned food items for a local charity. The schools have a goal to donate 5,000 cans. So we know that they want 5,000 cans. 12 schools have each collected 392 cans. 8 schools have each collected 22 cans. How many more cans need to be collected to reach the goal?" Well, that tells me that they haven't met their goal yet. So let's go ahead and check. If 12 schools each collected 392, we know we have to multiply that. So let's set up the area model for this one. 300 plus 90 plus 2. That's 392 times 12, which is going to be 10 plus 2. Set up our area model. Draw the lines where the plus signs are. And we have 10 times 300. That's 1, 2, 3 zeros. 1 times 3 is 3. Over here we have 10 times 90. That's 1, 2 zeros. 1 times 9 is 9. Over here with 10 times 2, which is going to be 20. Down here we have 300 times 2. That's 2 zeros. And then 3 times 2 is 6. Over here we're going to have 2 times 90. That's 1 0. 2 times 9 is 18. And finally we have 2 times 2, which is going to be 4. If we add these up, going horizontally, we have 3,000 plus 900 plus 20, which is 3,920. And then if we go across here, we have 600 plus 180 plus 4. That's going to be 784. Now we can add that up. And we get 4. 2 plus 8 is 10. Regroup the 1. 1 plus 9 is 10 plus 7 more is 17. Regroup the 1. And then 3 plus 1 is 4. So these 12 schools altogether have collected 4,704 cans. What about the 8 schools that collected 22 cans each? Well, I'm going to go ahead and set it up right up here. I have 20 plus 2. It's a little hard to see, but it's there. I'm going to set up my area model. 8 times 20 is 160. 8 times 2 is 16. So altogether, these 8 schools collected 176 cans. These 8 schools are kind of slacking. We're going to add that up to our 4,704 cans. 4 plus 6 is 10. 1 plus 7 is 8. 7 plus 1 is 8. 4 plus nothing is 4. So they've collected a total of 4,880 cans altogether, all 20 schools. Well, how far is that from 5,000? Well, we're going to subtract that from 5,000 to figure that out. 0 minus 0 is 0. 0 minus 8 can't do it, so it needs to borrow. But this 0 has nothing, so we're going to borrow from here. And now we can borrow for this 0. 10 minus 8 is 2. 9 minus 8 is 1. 4 minus 4 is nothing. So all they need, a total of 120 cans still to meet their goal of 5,000. Moving on to our next question. Number 5? Yeah, number 5. Mr. Lin's fart shop prepares 963 farts every hour. How many farts can be prepared in 50 hours? This is obviously every hour, and we want to figure out 50 hours. So we're going to do 963 times 50. Now there's a nice trick here. If we see that this number right here has a 0, we can actually get rid of that 0 and just put it right there and get ready to just multiply 963 times 5. So 5 times 3 is 15, regroup the 1. 5 times 6 is 30, plus 1 more is 31. And then 5 times 9 is 45, plus 3 more is 48. So Mr. Lin's fart shop prepares 48,150 farts in 50 hours. Now let me go ahead and do this one more time without crossing out that 0, just so you can see why I decided to go real quick and just write that 0. If we actually did it normally, we would have 963 times 50. That entire first row we know is going to be 0 times 3, 0 times 6, 0 times 9. All of it is zeros. And then once we're done with that, we cross it out and we fill in a 0 there. 5 times 3 is going to be 15. 5 times 6 is 30, plus 1 more is 31. And then 5 times 9 is 45, plus 3 more is 48. And you can see we get the exact same answer with a little bit more work. Let's go to number 6. Alright, so for number 6, I did make a mistake. If they each sold 18 cupcakes for 89 consecutive days, that means we have to do it twice. So let's go ahead and multiply that out one more time. We have 89 times 18. 8 times 9 is 72. Regroup the 7. 8 times 8 is 64. Plus 7 is going to be 71. Cross that out. 1 times 9. 1 times 8. Add it. We have 1,602. This is just Tegan. Ellie sold the exact same amount, so we're going to double that. So we have 32. Where's my eraser? We have 32,004. So they sold a total of 32,004 cupcakes for number 6. Chandler and Maya sold 13 burgers on Monday and 28 burgers on Tuesday. If the burgers cost $15 on Monday and $12 on Tuesday, how much money did they earn on Monday and Tuesday combined? Well, I know that they sold different amounts of burgers for different prices on each of these days, so this sounds like a 2 to 3 step problem. On Monday, they sold 13 burgers, and they cost $15 each. So we're going to do 13 times 15. And then on Tuesday, they sold 28 burgers for $12 each. So that's going to be 28 times 12. How much money did they earn on Monday and Tuesday combined? Sounds like I'm going to have to add these at the end. Let's go ahead and do our traditional algorithm here. 5 times 3 is 15. Regroup the 1. 5 times 1 plus 1 is 6. Cross that out. Put a 0. 1 times 3. 1 times 1. We're going to add now, and we're going to have 5, 9, 1. 195. And then for the other one, we're going to do 2 times 8, which is 16. 2 times 2 is 4, plus 1 more is 5. cross out the 2. 1 times 8, 1 times 2, and then add that. We're going to have 6, 13, 3. So on Tuesday, they earned $336. So all together means I'm going to have to go ahead and add these two together. And it's going to be 336 plus 195. 6 plus 5 is 11. 9 plus 1 is 10, plus 3 more is 13. 1 plus 3 is 4, plus 1 is 5. So on both days, they earned a total of $531. Number 8, Giuseppe read books about llamas for 25 minutes each day. If he read 89 days in a row, how many minutes did he spend reading in all? It's a very long book about llamas. We're going to go ahead and multiply this using the stacked method or our partial product strategy. We're going to start with 5 times 9, and that's going to be 45. And we're going to go 5 times 8, but this is really an 80, so that's going to be 5 times 80. And there's a 0 there, and then 5 times 8 is 40. Cross that out just so we know we're done with it. Moving on to this 2 times 9. This 2 is really a 20, so we're going to do 20 times 9, which is 180. And then we have 2 times 8, which is really 20 times 80. And we see here there's 2 zeros. And then we're left with 2 times 8, which is 16. Go ahead and add that. 5 plus nothing is 5. 4 plus nothing plus 8 plus nothing is 12. Regroup the 1. 4 plus 1 is 5. Plus 1 more is 6. And 6 plus 6 is 12. 1 plus 1 is 2. So altogether, he read 2,225 minutes. Moving on. Here we have number 9. Nakaya and Grayson are taking 141 llamas on a field trip. The trip costs $25 per llama. The trip is free for Nakaya and Grayson. How much money did Nakaya and Grayson collect for the field trip? So we know that out of all these people and llamas, it's Nakaya and Grayson are not paying anything. So we're only trying to calculate how much it costs for the llamas. We have 141 times 25. Let's go ahead and set up our area model. We have 100 plus 40 plus 1, and then 20 plus 5. Fill in our lines. First box right here in the top left is 20 times 100. That's 1, 2, 3 zeros. And then 2 times 1 is 2. Over here with 20 times 40, that's 2 zeros. 2 times 4 is 8. Over here with 20 times 1, 20. Down here we have 100 times 5, which we know is 500. 5 times 40, that's 1 0. 5 times 4 is 20. 5 times 1 is just 5. If we added all the way horizontally, we would get 2,820 plus 705. 0 plus 5 is 5. 2 plus 0 is 2. 8 plus 7 is 15. 2 plus 1 is 3. So Nakaya and Grayson collected a total of $3,525. Number 10. At Myers Park High School, 175 people attended the first basketball game of the season. Twice as many people attended the second game. Tickets cost $12 per person. How much money was made in all? Well, I know at the first game we had 175 people. But the second game, 2 times as many people went. And I know that 2 times 175 is just 175 plus 175. And that's going to be 350. So at the first game, we had 175 people. At the second game, we had 350 people. And at both games, tickets were $12 each. So I need to do 175 times 12, and then 350 times 12. So, or I can just find out the total number of people that went to both games. And that's going to be 350 plus 175. 0 plus 5 is 5. 5 plus 7 is 12. The 1 plus 3 is 4 plus 1 more is 5. So a total of 525 people went to the games. And they all paid $12 each. So now I can do 525 times 12. 2 times 5 is going to be 10. Regroup the 1. 2 times 5 is 4 plus 1 more is 5. 2 times 5 is 10. We finished with the 2. That means move to the next row. There's one number crossed out. 1 times 5, 1 times 2, and then 1 times 5. We can now add it because we have no more numbers. 0, 10, 2 plus 1 is 3, 1 plus 5 is 6. So they made a total of $6,300 in the 2 games. Moving on to our next question. William earns $34 for every hour he works. His goal is to earn $34,000, which shows the number of hours William will have to work to reach his goal. Now, this is actually sounding like a division question. But if we don't know how to divide 34,000 by 34, we can actually test out each of these answers. If I did 34 times 100 hours, I notice that there's 2 zeros, and then 34 times 1. This is not 34,000. This is 3,400. So I'm going to try the next option, 34 times 1,000. And I notice here that there's 1, 2, 3 zeros, and then 34 times 1. This is $34,000. So we know that William has to work 1,000 hours to reach his goal. If you want to, you can also test out the other answers just to really see if you did it right. We have 34 times 10,000 and 34 times 10. You'll notice that there's 1, 2, 3, 4 zeros, and then 34 times 1. And that's 340,000, and that's out. And then we have 34 times 10, there's 1 zero, and then 34 times 1, that's only 348, so that's also out. So our answer here is going to be 1,000 hours. Moving on, we are now at number 12. Maria has 33 llamas. Each llama eats 10 pounds of food per week. Which expression shows how many pounds of food the llamas will eat in 10 weeks? Well, if there's 33 of them, and they each eat 10 pounds each week, I know that's 33 times 10. But they want us to find out in 10 weeks. So I need 10 of these. So what that tells me is I actually have to do something like this. Well, I can also see here that there's no answer choice that looks like 33 times 10 times 10. Now, the order of multiplication doesn't matter. If it's all multiplication, you can multiply in any part you want first. So I'm actually going to do this 10 times 10 first, which is going to be 100. And I do notice there is an answer choice that says 33 times 100. So that actually is our answer for number 12, 33 times 100. You could also, alternatively, you could just solve it and it'll tell you whether you're right or wrong. If you do each llama eats 10 pounds of food per week, that means in 1 week, we have 33 times 10, which is 330. So altogether, the llamas eat 330 pounds of food. And then in 10 more weeks, we do another 10. That's going to be 3,300, which you'll see if you solve these out. This one right here is 330,000. This is 3,300. This is 330. And then this one down here is 33,000. So the one we want is the 3,300. 33 times 100. Moving on to number 13. LeBron James wrote the number 0 and 444 thousandths on the board. Which of the following statement is true about the 4 the 4s in LeBron's number. Let's check. The 4 in the tenths place is 1/10 the size of the 4 in the hundredths place. If you say something is 1/10 of something, that means it's smaller. And we know this can't be true because tenths are bigger or more than hundredths. So we know that this first option is out. The 4 in the thousandths place is 1/10 the size of the 4 in the hundredths place. And if we wrote it out, they're saying that the 4 thousandths is equal to 1/10 of the 4 hundredths. And this is actually a true statement. Let's check all our other statements just in case. The 4 in the hundredths place is 10 times bigger than the 4 in the tenths place. And we know that's not true because the 4 in the hundredths place is 10 times smaller. So we know this statement is false. And then our last one says the 4 in the thousandths place is 10 times bigger than the 4 in the hundredths place. And we know that's also not true because it's actually 10 times smaller. So that one's also wrong. So the only correct option here is the 4 in the thousandths place is 1/10 the size of the 4 in the hundredths place. Moving on to number 14. Which of the following mathematical statements is true? 0 and 1/10 is equal to 0 and 1/100. We can tell right away this is not true, but if you really wanted to check, you could line them up by their decimal point, and you can see that they're not the same number. 0 and 36 hundredths is greater than 0 and 371 thousandths. Let's go ahead and test that out. We have 0 and 36 hundredths, 0 and 371 thousandths. Fill in that 0 for that nice box shape. 0, 3, 7 is bigger. So we know this is also a false statement. 371 thousandths is larger. Let's check 0 and 48 thousandths compared to 0 and 8 hundredths. And we're going to fill in that 0 right there. Zeros, zeros. The 8 is bigger and it is eating the bigger number. So we know this one is correct. 48 thousandths is smaller or is less than 8 hundredths. Let's check that last one just so we have completion. 0 and 142 thousandths compared to 0 and 133 thousandths. Zeros, ones, 4 is bigger, so it is not eating the correct number. So this is also not a true statement. So the only correct one is 0 and 48 thousandths is less than 0 and 8 hundredths. And finally, number 15. A new school needs to purchase Chromebooks for 3rd through 5th grade classes and for the 2 computer labs. There are 24 3rd through 5th grade classes. The school plans to purchase 29 Chromebooks for each class. The school will also purchase 32 Chromebooks for each computer lab. How many Chromebooks need to be purchased? Well, if there's 24 classes from 3rd through 5th and they need 29 Chromebooks for each one, I know that's going to be 24 times 29. 9 times 4 is 36, plus 3. 9 times 2 is 18, plus 3 more is 21. We finish with the 9, so we cross it out and move to the next row. There's one number that's crossed out. 2 times 4 is 8. 2 times 2 is 4. We would cross that out, move to the next row, but there's no more numbers. 6, 9, 6. So the classes are getting 696 Chromebooks. Now, there's 2 computer labs, which says right here, and they each get 32 Chromebooks. So that's just 32 plus 32, or 32 times 2, which is going to be 64. Sorry, I wrote times there by accident. It should be plus. So we have 64 Chromebooks. So we're going to add that in. And we have 6 plus 4, which is 10. Regroup the 1. 1 plus 9 is 10, plus 6 more is 16. Regroup the 1, and then 1 plus 6 is 7. So altogether, they need 760 Chromebooks. Let's go ahead and move the screen down a little bit. We have 760 Chromebooks that we need. And once you're done with that, you'll hit submit, and that'll be your study guide that you study from.